Assalamu alaikum and good morning everyone. A brief introduction about myself. My name is Muhammad Abu Asali. I am a civil engineer by background. Graduated from the American University in Beirut in 2008. I have already around 6 years of experience in the infrastructure industry, specifically construction, mega infrastructure projects, including highways, bridges, and airports. I joined Autodesk about 4 years ago as an AEC technical specialist, focusing on the infrastructure solutions, specifically InfraWorks, Civil 3D, Navisworks, Revit, Recap, and others. Today's webinar is going to be about bridge and drainage design using InfraWorks. This is not going to be a deep dive webinar about all the features and capabilities within the software. However, you're gonna hopefully by the end of this webinar, you're gonna understand what are the capabilities of the software in terms of designing bridges, designing storm and sanitary networks, and how the software integrates with detailed design tools from Autodesk like Civil 3D and Revit. So let's get started. You're already aware about BIM, and BIM is definitely for buildings as well as for infrastructure. BIM is the Building Information Modeling new way of delivering projects and handling projects. It's based on a process workflow and is currently or always at the center of any BIM project with a 3D model that is intelligent, that is parametric, and that is moved from the planning to the design to the build and the managing states. We're going to see during the presentation how InfraWorks actually fits within this workflow. So InfraWorks was developed by Autodesk to cover the planning up till the detailed design stage, where Civil 3D or Revit or other tools carry over from there onwards. I'm not going to talk a lot about BIM because we've covered that already in the previous webinars and presentations. However, I would just like to highlight the importance of tools like InfraWorks at the conceptual design stage. What you're seeing on the screen right now is the Patrick-McLeamy curve, which highlights the ways of delivering projects. So if we look at the gray curve, this curve represents the 2D drafting-centric way of projects, meaning where most of the effort, time, the design is put during the construction and documentation stage of the project, as you can see here. Whereas, once we move into BIM, BIM focuses on all different stages of the project and specifically at the early stages. Why? Because from the project management, we know that the cost of making any changes to the project increases dramatically as we move from the planning to the preliminary to the detailed design and finally to the construction and handing over. And this is actually represented by the red curve you see on the screen. Also, the ability to impact cost and performance, which is represented by the green curve, decreases significantly once we move from the planning up to the handing over phase. So what Autodesk has implemented or invested in is basically developing a tool, which is InfraWorks, to enable our users to move from the centric delivery of 2D drafting and investing heavily in the detailed design stage to the preliminary or conceptual design stage. This shift actually saves the projects and saves companies and designers a lot of time and effort and enables them to have the ability to impact cost and performance much more. So let's see how InfraWorks actually helps you leverage the power of BIM early on in the project life cycle and how it can save your time and effort as well. Before I move forward, what is InfraWorks or InfraWorks 360, used to be called as InfraWorks 360, is a 3D modeling and visualization design tool that allows you to create 3D models up to city scale. We're talking about 1,000, 2,000, or even thousands of square kilometers. It enables you to visualize those models in a 3D compelling environment, analyze those models, and we're going to see how we're going to analyze certain design features within the software for drainage and bridges, evaluate sometimes the cost of the proposal or design proposal, and definitely be able to communicate that model or that project to the stakeholders, whether on an iPad, a desktop computer, or just from any mobile device using the web browser. Now, this is the user interface of InfraWorks. For those of you who haven't used it before, it's very intuitive, very user-friendly. You have the fly-out icons at the top, and these actually represent the basic features of the software, represented with the eye symbol, and then you have access to the road module, to the bridge, and the drainage module. Each one of these three modules has specific design features, which are either conceptual or sometimes detailed in nature. Now, InfraWorks, as mentioned earlier, covers from the planning up till the detailed design phase where Civil 3D and Revit take over. Okay, so why is InfraWorks or leveraging InfraWorks in our workflows so important? InfraWorks basically solves four major problems during the preliminary or conceptual design stage of any project, whether buildings or infrastructure. The first one being is that InfraWorks allows you to plan and design in context. You're able to bring in any type of data, whether 2D or 3D, a GIS, from any design tool, bring it into InfraWorks, aggregate it with the model, and then start your 3D intelligent design onwards. Second, it allows you to visualize and explore your design alternatives like no other tool available nowadays. It's very powerful, it's database-centric, and has a very powerful performance in terms of showcasing the 3D models with their textures, animations, the sun and cloud settings, along with the shadows. This is not the concern of our webinar. These two topics were covered in previous InfraWorks webinars. What I'm going to touch upon today and cover is basically show you how we can perform design analysis, sometimes material takeoffs for our storm network design, for instance, and how we can leverage the connection or integration between InfraWorks and Civil 3D and Revit as well to have this seamless movement or seamless transfer of design from the conceptual or preliminary to the detailed design, which means InfraWorks is serving as the basis for detailed design without the need to reinvent the wheel and start from scratch. So let's start with the first section of our webinar. But before I do so, before I touch upon the bridge design, I'm going to show you a couple of poll questions, and I would like your feedback on them, please. So the first one is, okay, the first question in the poll is, how often do you use InfraWorks? Is it never? Is it rarely, often, or always? So I'm just going to give you a couple more seconds. We just have like 60% of those who are attending voted already. Okay, thank you very much. So we're gonna have another poll question right now. Okay, hopefully you can see it on your screen. So what detailed design tool do you use for your projects within your organization or you're doing free time even? So is it Autodesk AutoCAD Civil 3D? Is it Bentley Systems, Inroads, or others, 12D, or any other design tool in the market? Okay, we're still getting the votes, so a couple more seconds. Okay, great. We move to the last poll question for today. Okay, did you attend any of our previous InfraWorks webinars? We've actually delivered several of those webinars since last year, and I would like to get your feedback on how many of those webinars you have already attended. Okay, so is it no, you've never attended a webinar on InfraWorks? Is it 1, 2, or 3? Okay, thank you very much. And let's go ahead with our webinar material. So the first section I'm going to talk about is bridge design capabilities using InfraWorks. Okay. Do you know that you can design 3D intelligent bridges in context within a conceptual design tool like InfraWorks? What you're seeing on the screen, for those of you who have never opened the software, never tried it before, is basically the terrain data with the satellite imagery superimposed and a proposed road alignment that was sketched or designed using InfraWorks road module. What you're going to see in a second is basically asking the software to create a bridge. We're just selecting the roads, the gizmos are all highlighted, we right click on the bridge on the road and we add a bridge. We start the bridge from a certain chainage to the last chainage or the end chainage, and within seconds the software will create a bridge with the deck, with the piers, with the foundations, and even the piles that are underneath the foundations. Not only that, it also includes the abutments, structures, and the bearings as well. So all of the components that make up a bridge are there, created in 3D, in context, and are all parametric. Okay, so let's have a look at those components with a little bit of zooming in. So there are different bridges within InfraWorks. You can design a precast, concrete precast bridge, or an Girder steel bridge, as you can see in this video. Now, the components are can be moved, can be shifted, or even can be deleted if necessary. So you might be have certain requirements of not having piers or having piers of different diameter or different shape. Instead of circular, you might have it as a square or rectangular. You may change the number of piers, the spacing between them, etc., etc. So whatever you create in InfraWorks is parametric and is flexible for modifications. Okay, so what do we mean by parametric bridge components? Parametric means if you change it, whenever you have a parametric model, it means that whenever you change one of those components, any related components will change or will adapt or update automatically. So let's have a look on one of those bridges which were created in InfraWorks. As you can see, once we change, so if I go back here, we're shifting one of the piers because apparently the preliminary sketch had one of the piers colliding or on top of a rail track. So by just clicking on that component and moving it using the gizmos, or actually typing in the spacing between the pier and the abutment, and then just placing it where it's supposed to be, just lifting our mouse from the pier, everything within the bridge will update. So you will have a look at this part of the bridge where the deck will actually be increased to accommodate for the change in moving the pier. So as you can see, the deck depth has increased to accommodate for the load and the change in the bridge structure. Not only that, once you zoom into the bridge itself, you have the flexibility of changing everything within that bridge, each and every component. So you select the bridge, and there is an asset card for each and every model or component within InfraWorks. There is what we call an asset card, which allows you to get more information about that component, as well as influence the geometry, the performance, or even the placement of that component within your model. So what we're doing in here, we're just updating the model by adding or reducing the number of piers. And by just typing in those numbers, the bridge will automatically update. So we had only 2 piers, now we have 3. We can change the type of the deck on the fly, and then have a direct information about the performance and the properties of that bridge. As you can see, once we've modified the end or start, ending or starting station, the terrain or the grading up to that station has also updated automatically. This is what we mean by parametric design. Change in one place is a change everywhere. Now, regarding the bridge girders, so we've talked that we have concrete and we have steel girders within our design tools. Now, these girders can be modified, can be grouped into several groups. So you might have a certain span of the bridge of one type, the other span of another. You can select the type of standard on which these girders are designed or modeled. So the standard the design standards internationally are all available within the software, and you can actually influence those girders manually by just typing in the values in the asset card or the properties palette. Once you update in terms of the values, the 3D model updates in the InfraWorks scenario automatically. Not only that, we do have definitely the bridge piers, the foundations, and we can create different or multiple proposals for that same bridge. So what you're gonna see in this video is actually a sample bridge created with too many piers. Here we're changing the type of one pier and we're asking the software to apply to the one after it, or even we can apply it to all of the other piers as one set. So there is a lot of flexibility for you as a designer. The same applies to any other component. So here we're seeing the foundation of the pier along with the piles underneath. So we can change the type of the piles. We can apply it to one or many of those piles, or else apply it to all at once with a single click. Now, there are many bridge components and bridge objects within the model, and InfraWorks allows us to save those components, or they save this bridge type with its piers, abutments, and piles as a template. This is what was done in here. So add bridge template to library. You can create a certain library or template that you usually use within your organization for later use and to save on time. Now, what you're saying here is actually we can have multiple scenarios. So here we have multiple scenarios, and we can have what we call a direct feedback on one or two parts of the bridge. We're going to highlight this part, and then we're going to increase the opacity of the girders or the deck so that we can see the girders and modify them. Now, the last thing we can do is definitely send this bridge to Revit, where we can view it, we can modify it, we can send this to robot structure analysis, but I'm going to touch upon that in a second later. Okay, so we're done with manually creating the bridge. We've analyzed it. We've seen for example, the components. We modified the components. What if I want to have a direct feel about the material takeoffs? InfraWorks directly and within a few clicks allows you to get an instant feedback about the concrete required and the steel to construct that bridge. So in this case, you can see that the precast concrete for the concrete deck bridge, these are the quantities required for the bridge, superstructure and substructure, and this is the steel required for the reinforcement. So what if we want to change the type of the bridge, as you can see here, from eye girders to plate girders? Everything updates automatically, as well as the quantities as well. And this is why we want to leverage B.Eng and in tools like InfraWorks. So as you can see, with single click, a few seconds, the precast is now 0, whereas the concrete in practice has increased in quantity, and definitely the structural steel as well. So a change in one place is a change everywhere, updates the quantities, updates the 3D model, updates the documentation, everything related to that model is being updated. Now, with the latest releases of InfraWorks, the product management developed something called component-based roads. This component-based roads are also very useful for bridges. So with a single click, these component roads will understand that this is a bridge underneath, and they will actually adapt or adopt the same road style off the road to that bridge as well. Now you can definitely change that style at any point in time. We've here changed just the median by changing or selecting an assembly from the library. You can replace those assemblies. You can actually check the cross section, and as you can see, it's very intelligent because it has actually detected that there should be a super elevation over that curve and created the super elevation depending on the design speed accordingly. Okay, also within InfraWorks, so once you're done with the conceptual design or having your first, second, or third alternative, InfraWorks allows you to analyze the performance, the structural performance of your bridge. This actually runs in the background and allows you to check for each and every component within that bridge. It highlights those girders that are not performing well in red, the ones that are okay in yellow, and the ones that have already passed the design requirements in blue. Once you change any of those components, you run the analysis again, and everything will update. If you change any of the components within the bridge, the line girder analysis panel will notify you that this report or structure analysis is out of date. You just have to run the analysis again, and everything will update automatically. Once you want to get the full report, you just click on that button over there, and you get a fully fledged report in a PDF file format that is about maybe 30 to 40 pages, detailing all the stresses, the strains, the momentum, the torsion, everything related to that bridge, which actually is coming from the structural bridge analysis from Autodesk. So this is just to be able to evaluate the performance of those alternatives and decide which one or two will be moved to the detailed design stage. Definitely you can open that bridge in the structural bridge design, but this is beyond the scope of this webinar. Okay, what else can we do within InfraWorks? So we've designed the bridge, we're happy with the performance. What if we want to check for the clearance envelope? We want to make sure that this bridge allows certain vehicles of certain height to pass underneath it. So on the fly, we can apply a clearance envelope with a certain height, certain width, and check for the bridge. If that vehicle is not able to move under that bridge, we can modify the height of the bridge using the profile view, which we've already covered in previous presentations, modify the elevation, hit update, and everything updates in 3D and in context. Design views. Also within InfraWorks and with the latest releases, InfraWorks allows you to have multiple views, similar like the ones we have in AutoCAD, Revit, or Civil 3D. So you can have the 3D compelling views, or you can have a conceptual view, you can have a wireframe, or create even your own view, which is suitable for your design purposes. Here we're creating a wireframe view, and as you can see with a single click, everything updates within the InfraWorks model. Not only that, even if you want to complete your design and you want to have certain roadside grading for the areas that are before and after the bridge, InfraWorks allows you to set grading zones with different grading material, and these material are also parametric, meaning the material has its own parameters in terms of cut and fill stability slopes. As you can see here, they apply automatically and they update the material takeoffs in terms of cut and fill. You can have actually split grading or create even a transition zone to move from one material to another material of a different property or stability slope. And these materials are actually saved within the palette, the material palette, and you can also create your own materials to be saved within the library and used in all of your upcoming projects. Okay, with InfraWorks, definitely you can create many different interchanges, flyovers, and many of our customers have created similar ones. You can check them on the InfraWorks gallery, which I'm going to touch upon later, but these are just simple examples that show you what can be done within InfraWorks directly and easily. Okay, also with InfraWorks, once you're done with the concept of your design of the bridge, you can create, as we mentioned earlier, different proposals. So it can be one type, different type, one bridge of a certain material, another material, different lanes, different alignments, different elevation. You can save all of these proposals within InfraWorks, and then at the very end of your design process, you can have the proposals managers where you can check, for example, what is the number of roads created, the total length of roads, total length of bridges, the quantities involved. This actually gives you an idea about the impact of your design on the existing conditions, plus regarding cost and maybe time constraints. Finally, and within the bridge design module, I'm going to talk about the integration with Revit and Civil 3D. So with a single click, as you're seeing in the on your screens right now, I just have to select the bridge, right click, and then hit on the send to bridge option. It will take a couple of minutes depending on the length and complexity of that bridge, and that bridge will open within Revit with all of its structural components as Revit families. So here you have the abutment, you have the piers, you have the foundations, the piles, the deck, the girders, and definitely the bearings. Even if you have certain street lighting poles, or as you see here, guardrail, these will be transferred automatically, seamlessly into Revit without any issues or problems for you to carry on with the detailed design later. Now, the major integration lies between InfraWorks and Civil 3D. The integration is seamless. So from within the Civil 3D ribbons, you can go to the Insert ribbon tab, and then from there you have a big icon for InfraWorks. You click on that icon, and then you can directly open any InfraWorks model on the fly. It needs very basic settings, like setting the coordinate system, and then selecting the area of interest, and maybe if you need to limit the number of objects imported, select the objects of interest. Like for example, I want to bring in the terrain, design roads and bridges from InfraWorks. I don't want to bring, for example, the planning roads or any drainage features. So it's up to you to decide. And integration is both ways. So any update in InfraWorks model is directly seen in Civil 3D, and any update in Civil 3D is directly seen in InfraWorks within 2 or few seconds after hitting the refresh button. So here we're opening an InfraWorks model from within Civil 3D. We've set the coordinate system and we're bringing in the model into Civil. As you can see here, we have the whole terrain, we have the road alignments, and even we've got the 3D model of the bridge with all of its components showing in Civil 3D. An example of leveraging InfraWorks with Revit and Civil 3D is from the city of Fet in Norway. This was created with Multiconsult. They've created actually 17 road alternatives and 8 different designs for the bridges, and they've simulated driving on them or through them using InfraWorks. So Revit was used for designing the bridges, Civil 3D was used for designing the road alignments. Those two were brought together into InfraWorks for visualizing and experiencing the project even before moving into the site or hitting the ground. Okay, this concludes the first part of this webinar, covering the bridge module and bridge design capabilities within InfraWorks. Now I'm going to touch upon the drainage design and analysis within InfraWorks. So what you see to the very top of the screen is this greenish icon with flowing water. This is the drainage module, which we're going to talk upon right now. Okay, so what are the focus areas for this presentation? The major functionalities and capabilities of the software lie in things like being able to analyze different watersheds. Second, being able to create, design culverts and analyze the performance of those culverts depending on certain rainfall data. Third is basically automatic layout of roadway, inlet, manholes, and pipe, along with the analysis of the performance of this network as a whole, as we're going to see later on. And finally, having a drainage catalog of objects like inlets, manholes, and pipes with different materials that is capable of being modified and changed depending on your requirements, and definitely finally be able to, once we're done with the design of the network, be able to extract quantities of all of those objects within our network, as you can see here in this table in the middle of your screen. Okay, so let's start with the watershed analysis. For those of you who use Civil 3D, you already know that these functionalities are already available within Civil, but it's great to see them within InfraWorks in a compelling 3D environment. So what is available in InfraWorks is being able to create or analyze the watersheds that are affecting or influencing a certain point. So you pick, for example, a point somewhere in your model and you want to see what are the watersheds contributing to that point. InfraWorks will do watershed analysis of the whole terrain, and then we'll highlight them for you with the streams as well. The second of all is being able to analyze the watersheds and create them in context for a certain selected road or even stretch of road. So it doesn't have to be the full road. You might be concerned about a certain stretch of road from a certain chainage to another chainage. You can select that area of interest, and then InfraWorks will run the analysis for you. And finally, be able to run the watershed analysis depending on certain hydrological inputs, like, for example, the method of calculating the flow, the peak flows, the runoff coefficient, the rainfall intensity, etc., etc. So watershed to a point actually allows you to delineate watersheds, meaning it will specify the boundaries of the watersheds. It will also locate the streams within those watersheds that will maybe intersect with the road or a point of interest. It will allow you to input your hydrological values, and this actually is this service is free of charge for analyzing a watershed to a point, but it's not free of charge for analyzing a watershed to a road or a stretch of road. So here what you're saying, we've just picked a point of interest, we've dropped a pen, asked the software to analyze, and then the watershed is created, delineated by this white boundary. You can change the color of the watershed, and then you see the stream in black, where the water will be accumulating and then hitting this runoff area at the very bottom. The asset card of the watershed provides you with information about the watershed itself, the slope, average slope. It will also give you an idea or option to change the hydrology method of calculating the flow, but this will be covered in the upcoming videos. Now, the second feature or capability is being able to analyze a watershed to erode. So here we click on watershed and stream crossings to erode, not to a point. And this is actually a cloud metered service, meaning depending on the length of the road, some cloud credits will be actually consumed from your Autodesk account. Now, if you don't want to run the analysis on the full length of the road, as you will see, we can select a point of interest, say at chainage 2 + 8, 9, up till to this point, for instance. And then we ask the software to run the watershed analysis for us. Also within seconds, the analysis will be run in the cloud, and then you will receive the end result. As you see, we have the watershed and we have the stream. Not only that, the analysis itself also highlighted the point of intersection between the stream, where the stream will hit the road, and where we're supposed to design or have a culvert in place. So minimizing our time of finding that point and trying to decide where we're supposed to design a culvert. Okay, so once we're done with the watershed analysis, whether for a point or a road, Autodesk specifies a point, as we've seen in the previous video, where a culvert should be put in place. Not only that, it also helps us design a culvert that is parametric and that will actually satisfy the flow requirements. So it will automate the culvert placement for us with a single click. Once we hit right click and then we add culvert, it will be created in its right location. It will allow us to do some culvert analysis regarding the flow. As you can see here, we have the downstream conditions, we have the upstream conditions, the flow, the speed of the flow, etc. And then we have the capability of reporting on that designed culvert for further maybe purposes later on. The culvert reporting is done in two ways. We have the easy way of generating a PDF report, which can be visualized on any web browser and then saved on your desktop computer. It showcases the high level elevation, the hydraulic grade line in the up and down. And as you can see, you have everything in terms of the culvert parameters, like the length, the size, the number of barrels, the type of those barrels, whether are they maybe squarish or rectangular or circular, and other parameters as well that were used to calculate the flow from the top to the very bottom of this culvert. So this is another representation of how the culvert will look like. Once you highlight and pick the analysis icon, you see all of the parameters. So if there is for example, if the downstream velocity is too high and is not satisfying your requirements, maybe you need to have a direct impact on the design by adding a barrel or increasing the diameter. This actually provides direct feedback for designers to update their models and satisfy requirements very quickly in 3D within context. So design a culvert manually. So you can actually design a culvert manually without the need to ask the software to design it for you. With a simple click, we click on the culvert, we select the type of the culvert, squarish, rectangular, etc. And a few clicks over the road, the culvert is created. We have the asset card. We have the option of changing the type, the number of barrels, the material of this culvert, which will also affect the flow or speed of the flow within the culvert itself. And this is created in 3D, which we can later open in Civil 3D for further or detailed design. Not only that, we can update the culvert very quickly, either by changing the parameters in the asset card, or even if something related to the culvert changes, like for instance, in this case, we have a road that is made up from, let's say, 2 lanes, and then we want to add few lanes to this road. What you will see in a second that this culvert has updated automatically. So now you can see that the length of the culvert is 117, for example, inches, whereas when we were with the few lane road, it was 92 inches. And this is when we talk about B.Eng, the parametric design. A change in one component of the road updates all related components like the network design, the bridges, and even the culverts that are attached to it. Design and analyze a culvert based on peak flow. So we've already completed the watershed analysis. We've delineated the watershed. We have an idea about the stream and where the water will cross that road. So what if we want to calculate the flow of that water that will go through this stream and will cross the road? All what we have to do is basically specify the area, or else specify the hydrological components, like, for example, mean annual flow, or for example, mean basin slope and drainage, and maybe, for example, like the runoff coefficient. Once you specify those components based on the calculation method, you will be able to, as you've seen here, the peak flows in cubic feet, for example, per second, or even international units. It's up to you to decide about the units. What is the 10-year peak flow, the 50-year peak flow, 100-year peak flow? All of these will be calculated, based on which you go to the road. You just have to right-click on that road and then ask the software to add a culvert. That culvert that will be created in 3D will actually satisfy the requirements of your peak flows automatically. So show analysis results, you tick the analysis results, and then you will see that the upstream flow, the velocity, and the downstream flow, etc., etc. If you change any of the parameters, everything in terms of those values will update automatically. So we increase here the number of the barrels, and then we go back into the software. We see that these parameters have been updated automatically. We can also export the design and analysis of a culvert data. So I know many of our designers don't want to have the analysis of the performance of that culvert in a PDF file format, but in an Excel file format. Well, you can export it in a CSV file. So here we have, for instance, 2 culverts for this road. These 2 culverts are showing in the profile viewer, which we've covered earlier. They show as blue dots or blue symbols. You just have to click on that symbol, and then you can be directly taken into that culvert automatically. So all what you have to do, click on it, right click, show in canvas. It will take that culvert in context. So what if we want to export the data? We can export into CSV file formats, which can be opened in Excel or any text editor. So as you can see, you have all of the details required for detailed design or for modifications later on. Okay, what about the road inlet and pipe analysis? Well, InfraWorks allows us to automatically lay out all of the pipes, manholes, and inlets and create them in a network format. Not only that, it allows us to have inlet and pipe analysis. So what you see over here is basically the tributary area which is contributing to that inlet. We can see the spread and the depth of water at each and every inlet. So how much the water will accumulate at each and every inlet cover. And you can see here, for example, the EGL and the HGL levels for each and every inlet, and you can see them in 3D in context. So pavement drainage, automatic layout of network. It allows you to do the analysis and definitely report on the quantities. This is how the network will look like once you reduce the opacity of the top surface. A very quick demonstration from within the software. You select any road of interest, you right-click, add pavement drainage to it, and then you just have to select the type of inlet, type of manhole, and type of pipes from the built-in library. You can definitely modify the sizes of those inlets, manholes, and pipes, and change the material of them as well. You can change the centerline offset of the manholes so that the automatic layout will be as per your own requirements, downstream offset, and many other parameters as well. Once you hit the enter button, you will see that those parameters were created in 3D, flushed with the top surface of the road, and they're all connected with pipes according to the drainage requirements. Hence saving you a lot of time of effort creating those manually yourself. Okay, what about editing or designing your network manually? What if I don't want InfraWorks to design it for me, or if InfraWorks did it for me automatically, I want to have the capability of modifying it? Well, you can actually design a network manually, and just by few clicks, as you've seen here. So by just clicking the first inlet, second inlet, third inlet, these inlets are created in 3D, flushed with the surface, and they're all connected with pipes all the way. And if I connect one to the other, it's also connected with another pipe as well. Now, also within InfraWorks, and to help our designers design those drainage networks very easily and quickly, there's an option to show the high and low points for you to understand how the flow will be going around your road or network. So this is the high point elevation, this is the low point. So I know that the drainage should be going from this point to that point in a descending fashion. Also, we're able to design the network manually. We can change each and every component of the design. So we can have one area made of HDPE, one area made of concrete. We can change the height, depth, and even the diameter of each and every manhole and inlet within our design. Not necessarily that all of our inlets or manholes or pipes will have the same material or same dimensions. And then we click on the quantities button. So once they click that road, all of the quantities of that road will be populated. The inlets, we have 12 of them. This is of the diameter, the manholes and the pipes by diameter. So we have pipelines of 329 meters. Maybe we have one diameter size, but maybe we also have other diameters as well. Now, the drainage network also takes into account the super elevation. So once we create a drainage network over a curve, using component roads specifically, the network will take into account this super elevation and will place the inlets in their right locations. So if you see here, we have one inlet to the outside of the road and the other one where the super elevation changes the slope inwards. We have the inlet placed on the inside of that road. You don't have, this saves you a lot of time and effort locating the low points, locating the locations where you have to place your inlets, taking into account the design requirements. And also places inlets in the median if need be. If this median is functioning like a channel, drainage channel, then also will place the necessary inlets and connect them with the main drainage network to cater for the flow. Not only that, you're able actually to design your outfall pipes, so it will take the drainage of all of your network depending on the rainfall content. Definitely you're able to input your own rainfall data in terms of IDF curves, and this will be taken into account once calculating the overall flow. And then you are able to create an outfall that will take all of the drainage into a low point or a maybe collection basin. Also, within InfraWorks, you're capable of draining a certain area. Let's suppose this is an existing network, and you want to drain all of the storm from this area or this site into your existing network by just clicking or manually editing the network. You can add a new inlet, connect it, have the tributary area depending on the site in hand, and enter the other hydrological components. And then very quickly you can run a simulation or analysis of the pipe. You see that this pipe is surcharged, meaning it's not able to cater for the flow. You either add more inlets and more pipes into the network, or you can just directly update the pipe yourself, or automatically ask the software to resize the network for you. So we have size drainage network, it will automatically resize it for you, and then you can inspect the performance to make sure that the pipe is not surcharged anymore. This hence saves you a lot of time and effort, placing the inlets, resizing them, checking for performance, and validating them for detailed design or even construction on site. Finally, you're allowed actually to see or analyze the networks underneath the ground to see if any of your proposed storm networks might clash with any existing utilities. Here what you see are manholes. You can have all of the existing networks in terms of electrical, storm drainage, potable water, or any type like IT or even telephone lines, all in one single model that is accurate to scale and allows you to visualize any problems that might occur on site during construction later on. Finally, there is a huge catalog within the software for all of the required components, and these can be modified very easily, as we'll see in a second, and you're able to communicate and export the required quantities of inlets, manholes, and pipes, detailed quantity of by diameter or by type. With the latest releases, the parts editor was introduced to InfraWorks. It allows an integration between InfraWorks and Autodesk Inventor, where custom-built 3D objects or components can be created and can be populated within the InfraWorks library or palette. So these serve a lot of purposes, allows you for better visualization, clash detection, and even quantification later on. Finally, and this is one of the major features within the drainage module, is the capability of being able to simulate and analyze flooding scenarios, not only on land but also as related to sea rise or maybe river floodings. This takes into account the partnership between Autodesk and a company called Hydronia. So you will have within the drainage module an additional one or two additional icons related to Hydronia for the flood simulation. The process is very simple. You basically start by highlighting the area of interest. You have to define the inflow conditions and the outflow conditions. And with the latest releases of InfraWorks, you're capable actually of having multiple inflow conditions and not one like last year. This is a very recommended improvement. So once you specify all of those parameters, then you hit the run simulation button, and then you can visualize those simulations by different surface elevations, by velocity or other parameters as well. The simulation will be run in meantime, and you will see it in color and in 3D. So meaning you will see, for example, which buildings or areas will be flooded first, at which elevation, and then after a few hours, which other areas will be flooded, etc., etc. So very engaging and very compelling. This is an example actually from the city of Pärnu in Estonia, and showcases the simulation done for the sea rise flooding condition. So once the parameters have been specified, you can see automatically how the seashore is being flooded until we get into this river, where the sea is actually merging with the river to flood the whole city in this scenario. It's also being used not only for specific cities or huge areas. If you have a certain building project, you want to create a building pad, and then you want to simulate, for example, the rise of water from underground or rivers, nearby rivers or seas, you can simulate the different proposals and then come to a conclusion whether you want to have this pad, yes or no, and at what elevation it should be to avoid any possible flooding scenarios. So here we're seeing another example, multiple inflow branches and outflow from one area. It's being actually used by many cities. This is from the city of New York, even running simulations that might happen as a result of hurricanes, and showcasing which areas will be flooded, or to which time, and to which velocity as well. Okay, for those of you who are interested to know about Hydronia and the partnership between Autodesk and Hydronia, this is the website, and this is the name of the company. You're actually able to download a free trial version of their software, which is Riverflow 2D, which works inside of InfraWorks. This 50-day trial is for free, after which you have to subscribe for their license, and the license costs less than $2 per day. So if we're talking about a year, you're probably going to pay around $700 or less for this simulation capability to be available within InfraWorks. So to summarize about the drainage features, in terms of analysis, we do create watersheds. We determine those watersheds and their streams flowing to a selected point or even to a tributary crossing area of a road. We do calculate the peak flow calculation if you have the required parameters. We're able to analyze a selected drainage network, create it, adjust the pipe, slopes and elevations, as well as the underground structures, whether they are inlets or manholes, and definitely inspect the performance of those pipes, see if there are any pipes that are surcharged, we need to modify them. Ask InfraWorks to automatically size the network to allow for this flow, and report on the quantities as well. And from the simulation side, we're able to run this flood simulation as we've seen in the latest couple of videos. Okay, before I conclude my presentation, it's worth noting that there are many users and companies worldwide that are using InfraWorks for multiple types of projects, whether bridges, drainage, roads, and highways as well. If you go to the any web browser and you search for the Autodesk InfraWorks gallery, you will find this web page where it will highlight for you certain success stories from around the world regarding the type of project that you have in mind. So if you type in, for example, I want to see bridge models or projects within InfraWorks, it will filter all of the bridge models for you, which you can see. You can also navigate if the user has, or the creator of the model has created a 3D model that you can navigate through. Some useful links. So you have the Autodesk BIM link, you have the AEC Collection, which has all of the BIM-enabled tools like AutoCAD, Civil 3D, Revit, InfraWorks, Navisworks, all put together. I highly recommend that you have a look at the AEC Collection. We have the Infrastructure YouTube channel, and this actually allows you to see short, medium, and sometimes long videos and webinars about certain workflows on bridge design, road design, drainage, anything basically related to infrastructure. We also have Autodesk InfraWorks product webpage. If you visit this webpage, you're allowed to download a 30-day trial version with the full capabilities, even those that require cloud credits or analysis in the cloud. Number 5, we have InfraWorks 360 YouTube channel. This is where you have very dedicated videos that allow you to learn the software very quickly and understand the capabilities within it. And finally, and most importantly, we have the Autodesk Civil community webpage, which you see to the very right of the screen. This page is very, very rich with content. You have the latest news from Autodesk. You have forums where you have the capability of asking the experts about certain workflows or workarounds or maybe recommendations to solve a certain problem. You have the Autodesk gallery for InfraWorks with all of the success stories. You have tips and tricks to save your time and effort while designing using InfraWorks and Civil 3D as well. You have the webcasts coming from the product managers, and these are usually very detailed and dedicated to certain topics, like, for example, drainage design. It will showcase what is possible using InfraWorks and Civil 3D. You have the ideas of what's coming next, the roadmap, what is Autodesk doing to develop the software, and learning material, as well as trying the software and being able to download the 30-day trial version I talked about earlier. Finally, just for those of you who don't know about the AEC Collection, the AEC Collection is a very powerful package from Autodesk and very efficient in terms of pricing. So you get all of these software in one single package for the price of maybe 2 software alone. So if you subscribe, for example, you want to subscribe to InfraWorks and Civil 3D alone, you most probably gonna be paying more than if you subscribe to AEC Collection as a whole, meaning it's very cost efficient. Not only that, you get with InfraWorks and AutoCAD Civil 3D access to the Revit full box, Navisworks Manage, which is for 4D, 5D simulation, clash detection and management, along with visualization tools like Autodesk Rendering, Autodesk Revit Live, 3ds Max, and others. Definitely, the 2D workflows are also supported, so you see a huge list of AutoCAD-based products. The plain AutoCAD, you have the architecture, electrical, Map 3D, MEP, Plant 3D, and others, all built within the same package. Finally, just to remind you that we've already covered many topics before during our previous webinars. The first one was in October 2016, overview about InfraWorks. The second was about road design in March 2017. We've also touched upon AutoCAD Civil 3D and its major capabilities in May this year. And today's we've covered the bridge and drainage design module. What we have planned for the upcoming webinars are things like InfraWorks for architects, urban and master planners. We have the traffic simulation and analysis within InfraWorks. We also plan to have a dedicated session about the geotechnical capabilities within Civil 3D using the Civil 3D geotechnical module, and dedicated webinars for how to move the concept design from InfraWorks to Civil 3D and Revit for detailed design, the best practices and the best tips and clicks. This is my email address. Please feel free to contact me at any point in time. Shall you have any questions or concerns? Also connect with me over LinkedIn or subscribe to my YouTube channel, where most of my webinars and the videos that I create are posted there within a few days from delivering them. Now I'll open the platform for questions. So feel free to type in your questions in the questions text box. And also be reminded that this webinar will be recorded and you will receive a notification by email with a link to download the recording later on. Any questions regarding the drainage, bridge capabilities, or even anything related to InfraWorks? Feel free to ask whatever you have in mind. Okay, so there is a question about the accuracy of designs in InfraWorks. InfraWorks is, yes, for conceptual design, but it's very accurate because it's actually geo-referenced and is to scale. So everything you design within InfraWorks is based on a design standard, has a certain coordinate system assigned, same like we do in Civil 3D, for instance. You specify in the coordinate system of UAE or the Saudi Arabia or any other country. And then you design within context to scale and accurately. So no issues about accuracy in regards to InfraWorks. Yes, you can definitely have access to the recordings. So I believe within a couple of days from now, you will receive an email notification with a link to a recording to download it in MP3, MP4 file format. Okay, I have a question from... Okay. I would like to know if Civil 3D... Okay, I know, Civil 3D... Okay. Okay, I would like to know if Civil 3D and InfraWorks, yes, there is a perfect integration between Civil 3D and InfraWorks. All of the objects that are created, sketched, or even imported into InfraWorks can be brought forward into Civil 3D. I'll cover this topic in my upcoming webinars. So there is a certain workflow, certain best practices. So I'll cover it in my upcoming one, but yes, rest assured that there is perfect integration between the two. And once you do any modification in one of the software, you just have to update the model in the other, and everything updates automatically. The process is very easy. Okay, another question, does InfraWorks has any other option to change unit of measurement? Yes, definitely. InfraWorks supports the metric as well as the international units. And this can be set easily from the model properties. And you can actually specify each and every measurement unit to each measurement type. So you might be able, for example, to specify the volume in cubic meters, but for the distance in inches or millimeters. So it's really up to you to decide on the units for each and every measurement type. Not only the unit, but also the number of decimals or the accuracy or the precision to which InfraWorks will be reporting those measurements. Okay, another question, is the rainfall analysis customized with Dubai Municipality standard? Okay, there are certain standards that are already built in within the software. Unfortunately, for the local market, we don't have anything built in. However, you can create that standard yourself and input the rainfall data into the software, and the software will be compatible with the UAE or Dubai Municipality standards. Definitely, because actually not only it's flexible to read data, but also flexible in terms of calculating the runoff or the flow depending on your own requirements. So there are certain built-in calculation methods, and there is also a user method where you can input your customized, for example, calculation parameters. Yes, in principle, there are built-in ones, but yes, you can create new ones yourself. This requires a little bit of customization, but yes, it is possible. Yeah, it's doable. So it's doable from actually the installation files of the software itself. So once you install it, you go into the drainage files, calculation text files, and you can create duplicate ones, name them differently, and change the parameters in them. Yeah, it's possible. Any other questions? Any questions regarding bridges? So now you know for sure that whatever you create in terms of bridges or bridge components in InfraWorks will be taken directly into Revit as Revit families to scale and accurate. For those of you who have any further questions, please have a look at the links that I shared with you earlier. Okay, we have one more question. Is it possible to integrate railway tracks design into road design and drainage networks? If I understood your question correctly, yes. Actually, within InfraWorks, you can design rail tracks, create the alignment, whether on grade, meaning on the surface of the ground, underneath, create tunnels for those tracks, or even rail tracks that are elevated like flyovers with piers and decks. This is possible, and you can transfer those rail tracks into Civil 3D as track alignments for detailed design. Okay, for watershed analysis, what available ground elevation sources with infra? Okay, basically any ground elevation model, any terrain model can be imported into InfraWorks. InfraWorks can read from over 50 or 60 file formats. So if you have a digital elevation model that is coming from, I don't know, from raster, from diff images, from even competitor vendors in the market like Bentley, like others, even from AutoCAD, or surfaces created from Civil 3D or surveying equipment can be brought directly into InfraWorks, and InfraWorks will read this information, create a digital elevation model in 3D, and if you have the satellite imagery, will superimpose it on top very quickly and very easily. And actually, I'm planning to cover this as well once I talk about the concept to detailed design stage. So we'll have hopefully a dedicated webinar on the integration between InfraWorks and Civil 3D. And I'm going to touch upon the different file formats and how to bring in such data from terrain or existing conditions to InfraWorks and then to Civil 3D, and maybe also back and forth if required. Any other questions? Okay, now automatically we get this, we have a very cool features called Model Builder within InfraWorks, which creates a 3D model of the whole city for free. The data is being freely shared by B.Eng Maps, SRTM, and other relations or partnerships with Autodesk. The accuracy of the data varies, but this is at least what we have currently free of charge. If you have your own ground data, surface data that is very accurate, you can just bring it into InfraWorks, update the model, and you're ready to go. Okay. You are most welcome. Okay, we've got one thank you message. Okay, so in order to save your time, since we've already covered 1 hour, please feel free to reach out to me by email, through LinkedIn, and subscribe to my YouTube channel. I hope that you've learned something